So apologies for not having this out sooner. I've been a little under the weather. So what's going to happen is I will record the first part of this tutorial today and Sunday, and I will try to have it out Monday afternoon at the very latest. I'm going to try to record them both back to back, but this does have to be a two-parter just due to the length of it. I thought I would be able to cover both, but I hadn't realized how long Edmentum makes something as simple as solving equations by graphing. Um, Solving equations by graphing should be really simple. You just plug it into a calculator and you're like, hey, that's where they touch each other. But as you'll see right now, Edmentum decided to make 43 slides about it. So let's get into it. As always, guys, please, please, please use your guided notes to help you with this. This does help out a lot. It helps the vocabulary and everything. And this is an independent studies course. So this is how you should gather information and learn. All right, so moving on to this, selecting an appropriate viewing. So this just talks about how to adjust the viewing angle. This might not be useful, but sometimes you might want to go outside of it. I'll show you how to do that in Desmos. All right, so moving on. So our goal here is going to be, in this lesson, we'll use graphing tables. So we're going to have to create our own formulas. It looks like is why this is going to take so long. Sorry, I kind of skipped that. Using graphing tables and successive approximation to solve polynomial rational absolute values and all of this. So let's get into this. Graphing to find solutions. It's going to be our main thing here. So if we're solving this, what we're going to want to do here is, I like doing custom. You could do linear, but you would have to adjust your slope and y-intercept. So I'm just going to not do that and just go straight into custom. This one just allows me to write them in. So they want you to get used to their graphing calculator as a resource. To be honest, we're going to use Desmos more. I believe they have a better calculator. Let me delete this graph though. I need to get rid of this one. How do I get rid of you? Well, I guess in this case, I will do this one just because I don't know how to get. Yes, I know. I'm trying to turn into three. Okay, this, that. Okay, so that's our other graph. Again, I prefer, oh my gosh, I prefer to use the custom equations, and we'll use that a lot more. So we got this going, and it looks like, did they want us to graph it and then mark it? So now we have to mark it, so we're going to click mark. Come on. Come on. Okay, so I don't know why I wasn't able to mark it, but you can see that the answer is right there after you submit it. So this would be the answer. So we could have solved this using substitution and we would get the same answer. I think they just wanted us to do the graphing a little later. So determine a method other than graphing that could solve this. We could use substitution to solve this equation. Since both are equal to y. Okay, so then we're going to do negative x plus 6 is equal to 3x plus 2. So because both of them are equal to y, I'm just setting them equal to each other. Now I'm going to want to move all the x's to one side. So I'm going to add x because I don't like dealing with negatives. I'm going to add x to both sides. So I get 6 equals 4x plus 2, and I want to get rid of that 2, so I'm going to subtract 2 from both sides. We get 4 equals 4x. So in other words, x equals 1. So after we solve for the variable, we plug it into one of the original equations. So we're going to plug it into one of the original equations. I'm going to choose the first one. So I'm going to say y equals -1 because it's a negative x plus 6. Therefore, y equals 5, which was our answer. And they chose to do substitution as well, and there we go. I didn't write the answer though, but you probably should because that's what they have there. Going into the next one, introduction. All right, so now graphing to find solutions. So when we're graphing to find solutions, we have these two equations. We can set them as two separate equations to solve where they would cross each other. All right, so moving on here. So for example, if we have these equation right here equal to 0, we can do it here, and this will help us find the 0. So we need to find where y equals 0. So here's a -3 and a 4. So by graphing it, by saying this is equal to 0, we just graph y, and then we look at where this is equal to 0. So this is similar to how we did the quadratic formula. So remember when we had to use the quadratic formula for this? We had to make sure that it was equal to 0, otherwise the quadratic formula would not work. So in this case, we have a left side and a right side. So we have two equations. Let's look back to the original problem. So we had this, and then we combined them. So what we're going to do is we have a left side and a right side. We're going to see where these equations, where these two equations touch each other. So in order to do that, we're going to use substitution, or they're using graphing, I guess. So here are two functions. So we're going to say that each function equals each other, and we end up creating this one function. So there's two functions. I'm really confused because they're trying to teach you one way and then they're describing the other. So what they're saying here is like, hey, graph them both, find out where they touch each other. The other method was a little easier because it was just one function. Oh, that's what they're saying. So when you have two functions, just graph both of them and see where they touch each other. That's what solving an equation means. Where do these two graphs touch each other? That's all they're trying to say here. They just make it sound very complicated and do a lot of work. All right, so we're going to solve this algebraically. So if we want to solve it algebraically, the first thing I want to do when I'm looking at this is to solve it algebraically. I'm going to want to add 2 to both sides. Wait, but I want both x's. Let's see what we have here. I want to get everything to the other side. Solve equation algebraically. The tricky part here is they're giving us two variables. Okay, so what I'm going to do is I'm going to multiply everything by x to get rid of that x. So by multiplying everything by x, I get x plus 1, and this is going to be squared. Let me put this in the equation editor for you guys. So I get x plus 1 go up squared minus 2 equals 2. This is easy because now that, 2x. Okay. I was like, that's a little too easy there. All right. So from here, what I can do is I can, oh, actually, I could have done that before. If I want to multiply everything by both sides, what I'm going to do is I'm going to do this. I'm literally multiplying everything by x. This already got multiplied by x. So we have this. Okay, cool. So how are we going to get this to? I was trying to be fancy with it, but you know what? I'll just do it that way so you guys can see all the work that I'm doing. X. I'm going to use their parentheses. A student showed me that if you use their parentheses, it actually gets bigger when you use fractions, and I actually kind of like that. I'm just multiplying both sides by x, and this ends up being x plus. I'm actually going to expand this x plus 1 into x squared plus 2x plus 1. This is you can just use the box method to verify that I got this right, but I'm just basically doing x plus 1 times x plus 1. So x plus 1 on the left, x plus 1 on the top, and then we solve for it. And oh, I wasn't supposed to have there. And all of this is going to be minus 2x. So I distributed this x to this part, and I expanded this. So I'm kind of doing two steps at once. And then this is just equal to 2. Well, if I distribute again, I would get x control up 2 plus 2 x squared plus x minus 2x equals 2. It's supposed to be a cube. I don't know where I got that squared from. Right from here, how would they want us to solve this? Because I don't think we've gone over how to solve cubes yet. We definitely haven't gone over synthetic division. Hmm. Hmm. I know how to solve this using synthetic division, but I feel. Give me a second. And again, you guys haven't done that yet. So I'm trying to do this with the skill set that you guys have used. So the only thing I can think of is multiplying everything by 2. Let's bring this over. These two are equal. Solve this using. I'm going to try doing another approach. Just add the 2 and then take the square root. So if I add the 2 to both sides, I apologize. I'm trying to think of how to do this with the knowledge that we've covered in class without getting into other topics that are a lot harder. So that's why you see me hesitating on a lot of these. Okay. So if I'm looking at this and then I want to take the square root of this, well, it can't equal 0. Then we have x plus 1 equals square root of 2 over x plus 2. If I plug in 1, I get 2. Okay, so the answer would just be 1. that's not really solving it algebraically. It's just kind of using logic. The square root of both of these has to be, uh, if we're thinking about this, I'm just going to say x equals 1, because if we plug in a 1, we get 2, and 2 over 1 is 2, 2 plus 2 is 4. I'm curious as to how they did it, because this is a very weird one. Okay, so what they did was they expanded it. That made it negative 1. Then they multiplied everything by x. And then they. Did they just box method this? How did they? Oh, they split it. I'm not a fan of how they're doing this. Oh, let's see. They moved it over. Okay, let me kind of show you what they're doing. So, what they're doing here, first of all, they're expanding this. So, this gets expanded to this. From there, what they're doing is they multiply everything by x. They're just not explaining it. I feel Edmentum, they do all these complicated things and then they forget to explain it. And then they're moving over this negative 2 over here. So from here, what we're going to do is um, we're going to group them. So now that we have 4 terms, we can just group them. So that was my mistake. I forgot about grouping. I was like, we have 4 terms, so we're going to solve this by synthetic division. They want to group this together. We can take out a negative 1 to do this x plus 1. We can take out an x squared. That makes this x plus 2. So both of these have this x plus 2 now. So what they're going to do is they're going to factor out that x plus 2, and then they're left with this x squared and negative 1, which is this x squared and negative 1 right here. And here, they're going to use dose. They're using dose right here, which causes this to happen. All right, from here, we have 2 answers. We have the x plus 1, x minus 1, and we also have the negative 2. So I only solved for one of those using my method. So they decided to use grouping, which I think is very effective. I was totally in the mindset of using dose and all of that, but that way you guys have an explanation of this now. All right, now let's solve this by graphing. Now here's the fun part. This is why graphing becomes a little more effective, a little fast, especially when we have nice numbers like this, but only when we have nice numbers like this, basically. So first things first, I'm going to use custom. Always use custom. It's just better when we're using these tools. This is an x plus 1, control up squared, minus 2. So that's our first equation. Let me plot it. Then I'm going to plot my next equation. So relationship, custom. And this one's easy. This one's just 1 equals 2. I'm going to use this to go over x. Plot that. So we have 3 answers here that you can see. So we have an answer here and an answer here. Does it want us to mark it? Let's see if I can actually mark it this time. Of course it doesn't let me mark it. I feel like Edmentum doesn't realize the limitations of their own program sometimes. But obviously there's an answer here and there's an answer here. Oh, they didn't have us mark it. Great. All right. So uh, what when does this equal each other? So this equals each other at negative 2 and negative 1. So negative 2 comma negative 1. Another solution is negative 1, negative 2. So negative 1 comma negative 2. And the final solution is 1 comma 2. So this is going to be 1 comma 2. All right, and those are our answers. They only give us the x values for some reason. When does this equal each other? Oh, x values. Derp. So you'll find that they're the same answers of this. Uh, Substitute the solutions into here. So they just want us to plug it in to make sure that these work. Why does this show that these are the solutions? So if we're plugging all of these in here, I'm just going to do it by hand. You guys can type it in. Give me a second while I find where the answers are. Okay. I want to grab these answers. Oh, wait. Here, I have answers right here. Okay, I was like, how am I going to type these in? Okay. So, first one, I'm going to do -2 plus 1 squared minus 2 equals 2 over -2. So this gives me 1 squared minus 1 over -2 divided by -2 is -1. Oh, I'm sorry, this should be -1 squared. Wait, yeah, -1 squared. So this is 1 minus 1, and there's a -2 here. Oh my gosh. This is supposed to be a 2. Equals -1. And -1 equals -1. Okay, so that works. So that's what they want you to do in for the first one, the -2. And then they want us to show the work for the next one, which is going to be -1. So now we're doing it for this one. -1 plus 1 squared minus 2 equals 2 over -1. This becomes -1 plus 1, 0 squared minus 2 equals 2 over -1. So this is -2 equals -2. So that one's good to go as well. Gonna erase all this. Oh my gosh. I didn't realize how long it takes to erase all that. Um, I wanted to keep that circle. That's the only reason why I didn't do much more. But next time I'm just gonna erase everything. It took too long. Squared minus 2 equals 2 over 1. So this is 2 squared minus 2 equals 2 over 1. So this is 4 minus 2 equals 2. And that's good to go. And they want you to explain why this proves it. So why does this show that these solutions match the calculated part? The x's make the equation true, that true, that means that the solutions work. The solutions are where the graphs meet. Of course, Des, because the x values are true in the original. I don't understand what they're trying to ask there, but like if it works basically. So because the x values equations are true, they satisfy the original equation. They represent the solution. These are the same solutions. Basically, they work and they're the ones on the graph. Use your own words. I think that was a really weird question that they wanted us to do. So now they want us to use the graphing tool. I'm going to choose to use Desmos. I know they want us to use theirs. I like Desmos. I just feel it's a better program. So I'm going to use Desmos. I feel Desmos also has it easier to adjust their window as well. So that's why I choose using Desmos instead of their calculator. So let's take a look at this. I'm going to do y equals -2 square root. And I love Desmos because Desmos actually understands regular typing commands, unlike Edmentum. Edmentum still needs to catch up on that aspect. And unfortunately, I've tried writing to Edmentum to fix some of their things. They usually don't choose a lot not to respond. Y equals -2 x squared minus 8x minus 8. Okay, so here we have the solution, these two solutions right here. And this is what I really like about Desmos also. You can just click on the solutions. It makes it so much easier. So if you're using technology, Desmos is a far superior tool to what Edmentum is offering. Use select appropriate selection windows. So this one, you literally just type in your answers. It looks like I don't see any other way to do this other than just typing in your answers. So that's what I'm going to do here. And I'm going to do -1, comma, what was it, -2. Okay, so I got those. All right, I'm going to do that. And then you can see their picture right here. They didn't ask for a picture, which I thought was kind of interesting. Um, but carrying on, suppose you're solving this equation algebraically. In which circumstances do you think solving algebraically would be a better strategy? Um, both sides seeing where they intersect. So when would solving it algebraically be a better strategy? Um, I think it would be a better strategy when they do not meet on the grid. When you graph the solution and the answers are not integers. And what I mean by this is when there's fractions, these are really nice because it's like, oh, they're whole numbers. But when they're not integers, it's probably better to solve it algebraically. So let's see what they say. Solving algebraically is when isn't available. Obviously, when it's not available, it's also possible to solve the problem by hand algebraically. Solving algebraically is a better strategy if you're there we go, integers. So obviously, if you don't have a graphic calculator, yeah, you have to do it algebraically. Desmos is very available now. Also, if they're not integers, sometimes they're not the best approximation. I've done things with Desmos on calculus, and he'll round a little awkwardly. So this one, I'm going to give myself a 4. Um, I was confused on how to start the first one. I was honestly going to use this process called synthetic division, which we have not covered yet. It's probably a semester 2 thing if we do cover it. Submitted. Okay. I was like, I submitted everything. All right. So moving on to this. Now we're going to be talking about absolute values and graphs. So pretty much everything's going to be the same thing. The other thing is we're going to have to account for positive and negative solutions here. So let's get into that. And you'll see what I mean by positive and negative solutions when we get into it. All right. So graph A, graph B. What do we do? Oh, we're just putting the number of solutions. Like, wait. So this one, it looks like graph A doesn't have any solutions. They never touch each other. This one, it looks like they have two solutions. This one looks like it climbs too high to intersect with that, so we're going to say two solutions. C, this one looks like it's not ever going to touch that one. It looks like we only have one solution for C. And this one we have two solutions. They touch each other twice and they're not going to touch each other again, it looks like. There we go. And that's literally just how many times they touch each other. That's how many solutions it has. All right, so solving this. So this is when graphing calculators obviously becomes a lot more useful. We're going to start talking about approximating our solutions. So that's going to be um, basically when we're dealing with fractions, successive approximations. So this is the idea of like we keep using a fraction, we keep getting closer and closer and closer to the answer, hopefully. So here is a good example of when we're going to use approximation. So if we're so they always use these little word problems. I feel these confuse you guys more than talking about it, but we're approximating because I see. They're probably talking about you can't always guess exactly where something is. You always have to approximate it. So going into this, we have these two functions. We are going to try to make them equal to each other. So when we get here, see how tiny it is? Like we have to like guess. So we have to keep guessing smaller and smaller numbers over and over and over again to try to get that exact spot. So this is one of the times when technology isn't the best ways to kind of solve for the answer. Accuracy of solution depends on graphing software where we intersect. Okay. So sometimes calculators are good. I honestly feel that calculators like this are outdated. This is what I used when I was in high school. Nowadays, I just tell everyone to pop it in on Desmos. I feel it's a lot more accurate and it's a lot more easier to use, frankly. Um, so type in the correct answer, round it to the nearest hundredth, use a graphing calculator tool. So we're just going to use this. I'm going to see how well. Yeah, it's a picture, so it doesn't even let me do that. So give me a second. Oh, you know what I can do? I'm going to use. I have two screens. You won't be able to see it, but this way I don't have to keep going back and forth. Take a picture of this and I'm going to put this onto my second screen so I'm able to see it. Unfortunately, you guys won't be, but this will prevent me from having to go back and forth when I'm plugging this in. And all I'm doing is literally just typing in the equation they gave me. One, and that's the first equation. So next equation. The beauty of Desmos 2 is you don't even have to write the y equals. It already assumes you're doing y. All right, cool. So my answer, two decimal places. Oh, and make sure it's from least to greatest order. So in other words, we're going from left to right. So our first solution is right here at 0.61. I'm going to say 0.61. Our next solution, I'm going to put the 0 because I don't trust Desmos. Let me unclick this one. Our other solution is right here at 0.84. I'm going to put 0.84 because, again, I just did a problem with geometry, and Desmos gets really picky with their decimal places. And our last solution is right here, which is 2.01. So I'm going to put 2.01. And that's just all you have to do here. Just type in both equations because this is an equation here, an equation here. And, oh, I have to carry the 2 over. Oh no, it's going to erase. Yep. That was just me being careless, unfortunately. 0.84. So always make sure you're looking at that. And now I'm going to see how picky it really is. I'm going to see if it does care about that 0. And it cared about the 0 there, but it was fine the other time. Oh, Yeah, this is really weird. So, yeah, this is what I mean. It is very picky. You saw how it didn't care about it for this, but it did care about. I'm assuming they have it programmed to do significant digits. So because I didn't put that point zero, it's like, hey, that's it's not accurate, which is kind of weird because here it's fine. It's very fidgety. Make sure you put your whole number and your two decimal places when it's asking for it. Otherwise, it's not going to count it. So we'll get into doing the approximations on the next video. So we're going to talk about how we can approximate these numbers for the better.